Alrighty folks, in this video we're going to go over how do we solve both exponential and log equations. Alright, just a couple of quick properties just to kind of refresh our memory that we're going to be using throughout this video is that if you remember, if we have log base b of b to the x power, we know that equals x. Right? Remember the bases cancel, we're left with just x. Remember, when the bases are not equal, log base b of x to some power p, remember we can apply our power rule and we can bring that power out front. Okay, so we have that rule. And then what else could we use here? We're going to also use both the product and quotient rules for logs. Just to refresh your memory, log of x over y is equal to log of x minus log of y, and log of x times y is log of x plus log of y. Okay, so we covered these extensively in a previous video, so if you need to go back and refresh, please go back and look at the previous video. All right, so here we go, log equations. Let's get to it. So for example, suppose we are asked to solve 3x is equal to 4. So we need to solve this for x. Well, remember I told you in previous videos, and I'll remind you again, logs and exponentials are inverse functions. They they undo each other, for lack of a better term. So when we have an exponential equation, we're going to apply logs. When we get to log equations, we're going to rewrite them in their exponential form. All right? Okay, so if I have 3x equals 4, what I need to do is I need to take the log of both sides of this, right? So how do I do that? Let me see. Let me actually change this real quick. Sorry about that. All right. So changing this, or excuse me, applying logs to both sides, we're going to take, in fact, I'm going to take a natural log. It makes no difference which log you take here. So I like natural logs. So natural log of 3x, of 3 to the x power, has to equal the natural log of 4. Remember, take logs of both sides here. Well, now on the left side, we're going to apply our power rule. And our power rule says we can bring that x out front. So the left side becomes x times the natural log of 3 is equal to the natural log of 4. Well, then what's our next step? We want to solve for x, so we divide both sides by the natural log of 3. And there is our answer. Oh, excuse me, not that. There's our answer. So then it turns out that x is equal to the natural log of 4 divided by the natural log of 3. And let's say they ask you to give an answer to 2 decimal places. Well, all you have to do is go to your calculator, type in the natural log of 3, divide that by the natural log of 4. And there we go. And to 2 decimal places, we get a 0.79. I'm sorry, I did that incorrect. It's natural log of 4 divided by natural log of 3. My bad. Natural log of 4 divided by natural log of 3. There we go, 1.26. It's approximately 1.26. Okay? All right, so once again, there's nothing special about the natural log there. I could have used the common log, a log of base 10. We would get the exact same answer. All right, don't believe me? Check this out. If I do log of 4, divide that by log of 3, we're going to get the exact same answer. So once again, there's nothing special about natural log. I just prefer it. Okay, so that's how you answer those types of exponential equations. Let's keep it moving. What if we had a slightly more complex problem? What if it was this? What if we had to solve 4x, 4 raised to the x power, is equal to 6 raised to the x minus 1. Let's say we had to solve this. All right. Once again, we're going to start off the same. We're going to apply, in this case, natural logs to both sides. So the natural log of 4x, 4 to the x power, is equal to the natural log of 6 raised to the x minus 1. We're going to apply our power rule. So on the left side, that means the x comes out front. So we have x times the natural log of 4 is equal to, and put this in parentheses, very important. All of that x minus 1 needs to be in parentheses, and it's going to multiply the natural log of 6. Okay? All right, so what do we do next? Let's see here. So my left side is still x times the natural log of 4. But on my right side, what I'm going to do is I'm going to distribute that natural log of 6 to both parts of my parentheses there. I'm distributing. So it becomes, on my right side, I get x times the natural log of 6 minus 1 times the natural log of 6, which is just the natural log of 6. Okay? All right, so what's next? Now what I want to do is everything that has an x attached to it, I want to move it to one side. In particular, I want to subtract this term to the left-hand side. So subtracting both sides of my equation by x natural log of 6, we get the following. On the left-hand side of our equation, we get x times the natural log of 4 minus x times the natural log of 6 is equal to a negative natural log of 6. Okay? And so now what we're going to do is we can factor out, on the left side, we can factor out an x. There's an x prevalent in both terms on the left-hand side. So let's do exactly that. If we factor out an x, it leaves us with a natural log of 4, because remember we're dividing out an x, minus a natural log of 6. That equals a negative natural log of 6. And then our last step here is divide both sides by the brackets quantity. So we're going to divide both sides by the natural log of 4 minus the natural log of 6. And so our final answer here is x equals a negative natural log of 6 divided by natural log of 4 minus natural log of 6. And let's get a decimal answer, and let's go 2 decimal places. Okay, so I'm going to go to my calculator. Our numerator was, I'm going to put my numerator in parentheses. It was a negative natural log of 6. So close parentheses for the natural log, close it up for my numerator, divided by, open up another set of parentheses for the denominator. And the denominator was the natural log of 4 minus the natural log of 6. ln 4, close up the 4, minus ln of 6, close up the 6, and then close up the entire denominator. Hit enter, and there we go. 4.42 if we are going to 2 decimal places. Okay? All right, let's solve some log equations. All right, suppose we're asked to solve this. Suppose we had log base 2, or excuse me, log base 3 of 2x plus 1 is equal to 4. Okay. So what we're going to exploit here, I forgot to write it earlier at the beginning of the video, but remember, if we have log base b of x equals y, if you remember, if that's the log form, we said to write the exponential form, we take the base of the log, we raise it to the other side of the equation. So this will be base b raised to the y, and it has to equal x. So because logs and exponentials are inverses, that's what we have to do here. We have to rewrite this log in its exponential form and then solve that equation. All right, so how can we do that? Well, we're going to take our base of 3 and we have to raise it to the 4th power. So 3 to the 4th power has to equal 2x plus 1. Okay. So yep, so just rewrote that log, and we got rid of the logs. Okay, so in your homework, if they tell you to rewrite the equation getting rid of the logs, this is what they're talking about. 3 to the 4th equals 2x plus 1. There's no more logs. All right, 3 to the 4th is, oh man, is it 81? Let's see here. 3 to the 4th is 81. Okay, so the left side of our equation becomes 81 equals 2x plus 1. And now this becomes just your basic algebraic equation. I'm going to subtract 1 from both sides. So 80 is equal to 2x. And then divide both sides of my equation by 2. And I get the answer that x is equal to 40. Okay. And so real quick, very important. Very, 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 very important. When it comes to log equations, check your solutions. What I mean by that, recall that the domain for log base b of x was in a previous video. Remember, the domain was from 0 to positive infinity, meaning we can only take logs of positive numbers, of positive values. So the way you can quickly check yourself is, look, okay, just because that 40 is positive, that doesn't mean that that might be your answer. It matters. What you need to do, is you take the 40 and you plug it into your equation. Right? So if I come here and if I do log base 3 of 2 times 40 plus 1, the question becomes, does that equal 4? It does, because inside my parentheses, 2 times 40 is 80. 80 plus 1 is 81. Does that equal 4? It does, because 81, as we saw, is 3 to the 4th power. And we know from before that if the bases are the same, the answer is just 4. So this works out. Sometimes, and we'll see a question in a little bit, sometimes we're going to end up with values of x that are what we call extraneous solutions. They are not correct solutions, and we should not include them. How do we know that we shouldn't include those answers? Is whenever you plug in that x value, if you get a negative argument for your log, that answer is automatically excluded. All right, let's keep it moving. Let's try another one here. For example, let's say we're asked to solve this one. Log base 2 of x plus log base 2 of x minus 6 is equal to 4. All right. First order of business is let's combine the left side of our equation into a single log. How do we do that? We talked about it at the beginning of the video. We're going to, we're going to bring them together as a single equation using this right here. Single log, using that. So, what does that look like? Get out the way. All right, so we're going to get log base 2 of, and because both of these are positive coefficients, we're adding them, they're going to multiply each other. X times x minus 6, and then this has to equal 4. Okay, so we brought those together as a single log. Remember, we said in previous videos, if you have positive coefficients, they go in the numerator. So both logs are positive. That's why they're both going to be multiplying each other in the numerator. Okay, next step is to rewrite this in exponential form. We take our base of 2, we raise it to the 4th power. And then that has to equal the argument. What we're taking the log of, in our case, is the x times x minus 6. So once again, if your homework question says, what's the equation? Rewrite the equation, not using any logs. This is what they're talking about. All right, now what do we do? 2 to the 4th is 16. 16 equals, and what I'm going to do is I'm going to distribute my x on the right-hand side. We get x squared minus 6x on the right-hand side. And then I'm going to subtract my 16 over. So 0 is equal to x squared minus 6x minus 16. And you guys know what's going to happen. We're going to have to factor. So because we need to multiply to a negative 16 and sum to a negative 6, that means this factors into x minus 8 times x plus 2. And from this equation, we get two solutions. We're going to set both of these equal to 0. X minus 8 equals 0. X plus dos equals 0. You get two potential solutions. X equals 8. X equals a negative 2. But I'm begging you guys, check your solutions. What do I mean by that? Remember, we cannot take the log of a negative value. So let's look at 8. If I take 8 and plug it into the original equation, I'm going to have log base 2 of 8. That's valid. I can take that. That's some number. Over here, we're going to have log base 2 of 8 minus 6. That's log base 2 of a positive 2. So yes, that is going to work out for us. So x equals 8 is a solution. We can box that up. That's one solution. What about negative 2? Negative 2 is going to cause an error because when we try to take a log base 2 of negative 2, we're going to get an error. To prove it to you, if I take log of any negative number, even though my base here is a 10, it's true for any log. A log of any number is an error. Okay? So with that being said, there's only one solution here, and that one solution is x equals 8. Check your solutions. All right, let's keep it moving. Matter of fact, let's make it clear here. Remember, we can't take the log of a negative number. Okay? All right, we can't take the log of something negative, so that's how you check your solutions. All right, here we go. Just a few more. Let's say we had this one. Let's say we had log base 2 of x plus 30 minus log base 2 of x plus 2, and let's set that equal to log base 2 of x. Okay, so this is similar to what you'll see on the homework. All right, first step is, once again, let's combine our left side into a single log. We did this in a previous video. This time we're going to divide them because of that negative sign. So it's log base 2 of x plus 30 divided by x plus 2. This equals log base 2 of x. Okay. What we do now is we're going to exploit a certain property. A certain property says this, man, if I have two logs of the same base and they have to equal each other, well, the only way these two values are equal is if the arguments are equal. Okay? So what this equation reduces to is that for this equation to be true, I need x plus 30 over x plus 2. I need that to equal x. Okay? So before, just notice the difference. Here before, when we combined everything, we were left, in the previous example, we were left with a constant on the right-hand side here. That's when we had to rewrite it as an exponential. You have to do that. When there's a constant on the right-hand side, rewrite it as an exponential. But in this case, when you have one log equal to another log and they have the same base, well, this quickly simplifies to, oh, these two arguments have to be the same. That's the only way that these two logs will equal each other, if they have the same base. So once again, if the homework question asks you, what's the equation with no logs? This is the equation. X plus 30 over x plus 2 is equal to x. And here we go. We're going to solve for x by getting rid of our denominator. So we multiply both sides of the equation by x plus 2. So we have x plus 30 is equal to x times x plus 2. On the right-hand side, we're going to distribute the x. All right. And then we're going to move everything to one side, set it equal to 0. So I'm going to subtract x, subtract 30. Subtract x, subtract 30. So 0 is equal to x squared plus x minus 30. I'm going to factor the right-hand side of my equation. Okay, and that's going to factor into x plus 6 times x minus 5. I have to multiply the negative 30, add to a positive 1. Set both of those factors equal to 0, and we get two potential solutions. X equals a negative 6, x equals positive 5. And for the reasons we discussed earlier, check your solutions. If I plug this -6 into my equation, what's going to happen? I'm going to get an error because, let's see here. I'm not going to get an error here. -6 plus 30 is a positive 24. We're good there. But a -6 plus 2 is a -4. We're going to get an error. And then on the right-hand side, the log of a -6 is also going to give us an error. So for that reasoning, -6 is not a solution, but 5 will work out for us. All right, 5 plus 30 is okay. That's 35. 5 plus 2 is 7. We're good there. And then log base 2 of 5 is okay as well. And I know y'all don't care, but really quickly, we can easily show why that's the correct solution. Like I said, let's plug in 5 for x. So what we're saying is that log base 2 of 35 minus log base 2 of 7 has to equal log base 2 of 5. Okay, I just plugged in 5 for x. Well, remember the quotient rule. Log base 35 of log base 2 of 35 minus log base 2 of 7. We can rewrite that as log base 2 of 35 divided by 7. That equals log base 2 of 5. And 35 divided by 7 is 5, and that's why we get a true equation. Okay? All right, so I know it seems kind of random, but that's what these logs are doing. All right, apologize for the length of this video. Let me give you one more, and then I'll get out of your hair. Last one, and I'm going to do it quickly. Log of x plus log of, let's say, x plus 3. Let's say that equals log of, let's say, 28. All right. Bringing our left side together as a single log is going to be log of x times x plus 3. And that equals log of 28. Okay. Once again, our log is of the same base. In fact, the base is understood 10. So that means that the only way that this equals if the arguments equal. And so our arguments are x times x plus 3. We set that equal to the argument of 28 on the right-hand side. We distribute on the left side. X squared plus 3x equals 28. Subtract the 28 over. Okay. We're going to factor the left-hand side. So multiply to negative 28, but add to a positive 3. So that's x plus 7 times x minus 4. And then we're going to set both factors equal to 0. We get negative 7 and a positive 4. Okay. And then let's check the solutions. Negative 7, will that work? No. If I try to take the log of a negative 7, I will get an error. But if I take the log of 4, that should work. Log of 4 plus 3, that would work. And does that equal 28? It will if you do the work. So that's our answer. Alrighty, folks. See you guys in the next video.